All right, students, it's time to get back to work. So, we've got lesson 4, 5 in SAVVAS, where we're going to be finding equivalent expressions and writing them in different ways using distributive property and combining like terms and factoring. So, you ready to get started? Let's go to the board.
Topic 4-5.
Welcome back, students. Now that we're at the board, we're going to look at writing equivalent expressions through factoring. It works like distributive property, just in reverse. In topic 4-4, we looked at how to get from this part, 3 times x plus 4, and get to a two-factor system, 3x plus 12. That happened by multiplying 3 times x and 3 times 4. And that gave us 3x plus 12. Now we're going to look how to do it in reverse. Now we'll look at factors, numbers that are multiplying together to give you a product. For example, the factors of 12 would be 3 and 4, because 3 times 4 gives you 12. Other factors would be 6 and 2, and then 12 and 1. All of these factors can multiply together to give you 12. Then we have factors of 8. The factors of 8 are 4 and 2, 8 and 1. Now we're going to teach you how to find the greatest common factor, or GCF. The greatest common factor is the highest factor that both terms have in common. So for 5x minus 30, we look at the common terms for 5 and 1. And then 30 has 6 and 5, 10 and 3, and of course 30 and 1. Now we look for the highest common factor between the two terms. You can see with 5, the highest term is going to be 5. Now if we can find that same common factor for 30, then we can figure out that that is the greatest common factor, which is 5. For 12x plus 3, again, we'll look at the factors for each of those terms. For 12, the factors would be 6 and 2, and 12 and 1, and 4 and 3. For 3, the factors are simply 3 and 1. So again, we look for the greatest common factor between the two terms, which in this case will be 3. So our greatest common factor is 3. Finally, we'll look at 8x plus 32. So let's write the two terms down. We have 8 and we have 32. The factors for 8 are 4 and 2, and 8 and 1. For 32, the factors that we get that are going to help us multiply to get it are 16 and 2, 8 and 4, and then 32 and 1. We look for the greatest common factor between them, and we can find an 8 in both terms, which makes the greatest common factor 8. Now we're going to learn how to write an equivalent expression through factoring. We have 6x minus 24, so let's write down the greatest common factor. We have 6 and 24. Common factors of 6, we have 2 and 3, 6 and 1. For 24, we have 12 and 2, 6 and 4, and 8 and 3. If we look at the greatest common factor, we have 6 in both terms. So the greatest common factor is going to be 6. Now that we know that, we can put it out in front and add our parentheses. Then we divide each term by that greatest common factor and see what's left. If we divide 6x by 6, we simply get x, or 1x, but we don't really write the 1. Then we take the negative 24, we can put the minus down there, and 24 divided by 6 gives us 4, so our answer would be 6 times x minus 4. Now let's do review. First, we're going to try to find the greatest common factor of 4x plus 16. So we're looking for the greatest common factor, which is going to be 4, because I can divide 4 out of each term. For the second step, we're going to divide all the terms by the GCF. So 4 divided by 4 gives us 1, and 16 divided by 4 gives us 4. For the third step, we're going to place the GCF outside of the parentheses. Then 4, we replace the divided terms. So our answer is 4 times x plus 4. All right, now let's look at a couple examples from the book. We're going to factor completely the algebraic expression 21a plus 9. Factors of 9 are 3 and 3, but we don't have to write it twice. Then we have 9 and 1. The factors of 21 are going to be 7 and 3, and then 21 and 1. Since the greatest common factor that both terms have is 3, 3 will be our GCF. Now we're going to place the 3 outside of the parentheses. The next step is to divide each term by the greatest common factor. 21a divided by 3 is going to be 7a. Then 9 divided by 3 is going to be 3. So our answer is 3 times 7a plus 3. Next one, factor the expression negative 18a minus 10. Now in this example, they're asking us to create an equation with each expression or integer factor. They've already kind of given us a clue that since both these numbers are even, we can multiply by 2 to something to get the answer that we're looking for. 2 times negative 9a will give us negative 18a. And 2 times what? Will give us negative 10. 2 times negative 5. So if we were going to go ahead and do this, 2 is our greatest common factor. Then our first term is negative 9a. And our second factor, since it's a negative, will be minus 5. And it checks out. All right, guys, I hope this was helpful. So lesson 4 and 5 is complete. You should know now how to write equivalent expressions using distributive property. If you have any questions, leave a comment below. Until next time, see you later.